Hi, everyone. Lovely to see you all. We've got everybody on mute right now, and as we start admitting people, and when we get going in just a minute or two, we will give you some more instructions. So good to see everyone. I hope everyone's surviving the rain without too much drama. So we'll give it another minute because I think there's a couple other people who may want to come on. Folks, can everyone see the chat on your screens? Just checking to see if that's visible.
And since everyone's muted, maybe use a reaction. Give us a thumbs up down there in the Zoom.
Yeah.
Or reply in the chat. Perfect.
Okay. All right. Chris O'Day.
Oops.
All right. Let's just give it one more minute. Looks like folks are still signing on. All right. Okay. Admit. All right, let's get this show on the road. Lovely to see you all. Thanks so much for joining us tonight. I'm very excited to share the results of a lot of hard work by the Moffatt and Nichol team and Dave Ravel and his team. Just a couple of housekeeping things. If you would be so kind as to sign in the chat, that would be really helpful. And thank you we decided to record this because we are also going to ask that you put your questions in the chat. And then I wanted to remind everyone that everyone is muted except for the speakers for tonight for now. And when we get to the Q&A part, we can change that. But wanted to give them a chance to get through their presentations. And I also wanted to do a quick reminder that this is not an official public hearing. So if you have comments that you would like to have into the record, it's really important that you send them via the link that's in the chat. And it's also on our website because we're not collecting formal comments this evening. And so with that, I'm going to turn it over to Dave, and he's going to run the meeting for us.
Hey, everybody. Thanks for coming. Hopefully everybody can see my screen here. Good. Thank you, Clark. I saw you first. We're going to talk tonight about the Topanga Surf Quality Impact Assessment, which is sort of a subset of the larger restoration effort, and the EIR just came out for public comment. So please, I know there's a lot of interested parties here who are interested in not just the surf, but the whole project itself. There is a link here, and it's the same one in the chat that Rosie just said. So please stay involved. I wanted to sort of define sort of the scope of what we're going to be talking about tonight and what the project was that we were asked to do. And it was really, and I want to commend everybody who's been involved, because it was sort of a grassroots effort working with the RCD that got this surf quality impact assessment included before the EIR came out. So as the alternatives were evaluated, this became a part of the decision and alternative framing. So there was technical information that became very valuable to assessing project alternatives. And that's very unique. That's the first time that I'm aware of in California that we've done it this way. So I think it's a great precedence. The scope of work we're doing is to evaluate the Topanga Lagoon Restoration Project and its alternatives to determine whether the surf quality could be impacted by the restoration. And then we provided a background, a couple of background technical reports for the EIR process. And those are now available, as well as some of the technical appendices. The scope for Moffatt and Nichol was to do morphological modeling, looking at different sort of rain and drought and regimes, and for the different alternative restorations, and then to look at where the nearshore sediment placement might be. Our scope at Integral Consulting was to sort of work closely with the surfers, identify, we had a surf focus group to begin with, and that helped us frame some of the analysis we were working on. And then we got into some surf quality modeling evaluation. And then we looked at how the shoreline evolution, using a model from, sort of adapting a model from the U.S. Geological Survey, would affect sort of beach widths and stuff with sea level rise. So there's going to be two speakers tonight. Weisha Jin from Moffatt and Nichol is going to talk about sort of the morphological modeling and nearshore sediment placement. And then I'll talk specifically about the surf quality impact assessment. So I'm going to stop sharing and turn it over to Weisha.
Thank you, Dave. Can you see my screen?
See the
Yep,
work.
looks pretty good.
Okay, thank you all. This is a presentation.
Weisha, we're seeing the your Word document.
Oh, wrong one. Let
Not the
me
presentation.
reshare.
By the way, while Weisha's getting this up, if you go to the website for the draft environmental impact report and appendices, you can download the appendices that are the full reports that they're providing the results of tonight. So those are available now, the whole thing. And we look forward to any further comments you have after you've had a chance to read them.
Okay, thank you, Rosie. Good evening, everyone. And this Moffatt and Nichol has done 2 modeling studies. As Dave pointed out, we did shoreline morphology modeling, look into potential project impact, and also looked into the beneficial reuse by placing excavated material in the near shore, looking into how the material disperse and benefit the beach. So 2 modeling, I will run through both modeling in order to save time. And the first presentation was based on a presentation Chin and I put together, presented in CSVPA conference. So we'll get into the project location. I'm sure you all are very familiar to the project site, but I will just point a couple of things so that you know what I'm referring to. Topanga Point, we are mainly referred to the big Cobble Delta in this area, and then the Cove Beach kind of between Topanga Inlet to Mistress Point, and Rattlers Beach kind of east of Mistress Point. So that's kind of what I was referring to. Other than that, I think you are all very familiar with this project. The red box in this area is the boundary of the nearshore placement area. I'll get to that very soon. And the purpose of this first shoreline morphology modeling is to look at the potential impact of proposed changes, including lagoon reconfiguration and grading, removing about 250,000 cubic yards of material previously placed as a fill into the original lagoon area and then placed to near shore. So that is one component. And the other component kind of labeled as ABC. On the graph to the left is the lifeguard building and helipad will be relocated to higher ground in this area to be more climate resilient to the rising sea level. And this another component C here is replacing and lengthening the Pacific Coast Highway Bridge to improve the fish passage. That's one of the main objectives of this restoration project. So the public and all you, including you guys, have some concerns. So the concerns are the Topanga Beach, the Cove Beach, the eroding Cove Beach, the beach west of helipad, basically, and then the other is this area too. So those are some eroding beach and also surf quality at Topanga Point, which Dave will be focusing on that. And then a few more specific questions were raised in the public meetings. How will the adjacent beaches be affected by the project, which I kind of touched a little bit over here. Whether the beach will continue to erode once helipad and lifeguard buildings are relocated. What is the regional context for beach erosion and how is that being addressed by the project? And then the last one, what actions can we take during the next stage of design development to direct flows to the west so that kind of promoting a westerly breach? And I think you are already familiar with this. I will be very brief on these alternatives. So alternative 1 is no project existing condition. Alternative 2 is the maximize lagoon habitat alternative. The ranch motel will be demolished, expand the lagoon to the east. And alternative 3, it will be a smaller habitat expansion with ranch motel being retained. And alternative 4, compared to alternative 3, the main difference is it's also a reduced lagoon area compared to alternative 2, but the PCH is aligned slightly to the north. So that will provide slightly bigger beach area compared to alternative 3 and 2, and also partial ranch motel retention. And in all these alternatives, the circle area is the helipad will be relocated to a higher different location, and the blue rectangular is the lifeguard building will be also relocated to a high ground. And also there's the one feature as we asked by public whether the project can promote a westerly breach. Clark was instrumental on that, reviewed all the historical creek alignment. There was historically the creek alignment, one of the alignment was going slightly to the west. So all these proposed alternative has a pilot channel we call, basically grade down to mimicking the historical creek alignment. So that would help promote westerly breach. And a state of our three-dimensional numerical model called Delta 3D model was used to perform the morphological change. The model is a modeling suite, include a wave model. So that model the wave-driven radiation stress, shear stress is input into hydrodynamic model. And together with the hydrodynamic model modeling the fluvial flow tidal exchange. That's the hydrodynamic component, and then all these feed into a sediment transport morphological model. It's an interactive coupled advanced numeric modeling suite. And this graph shows the numerical modeling grids. Basically, at each model grid point, depth, elevation, and coordinates are assigned so that the water level, velocity, wave height, wave parameters, and sediment transport are calculated. So as you can see, the domain is really big, from Big Rock Beach all the way to Gladstone PCH Beach. This is the hydrodynamic and sediment transport modeling domain. The other feature is the model grids a little bigger. The offshore area, when it comes into project area, is much denser. And this is a wave model. This is even bigger model domain to drive the sediment transport and hydrodynamic model. So this is a wave domain. And one of the things we looked into is the sediment characteristics, whether the material to be excavated from this field area can be placed at a beach. So we took quite some surface grab samples along these two red dots and transects we called, and then analyze them, looking into their grain size and sediment color. And then a lot of geotechnical borings were conducted on the to be excavated area to test for quality, to see whether the materials are clean, suitable for beach placement, and also look at the grain size and the color of that, whether they are compatible with the current beach material. So figure to the right, as you can see, the top is currently the green, come from the green dots. You know, the sediment grain size range, as you can see, very similar from 0.1 millimeter to like 20 millimeter. And the beach graph samples are also in a similar range, except we didn't grab those bigger rocks or the cobbles. You know, you are very familiar. The cobbles can range from a couple inches to a couple feet. So the range, if we extend to the cobble, definitely we can make sure that the material excavated from lagoon, their size are well within currently the size you will find in the beach or in the nearshore area. And model calibration is an important part. We tune the model, make sure the model represents the bathymetric condition of the site, and also adjust model parameters so the model can predict what is recorded. For example, in the middle, showing the two sets of data. The red cluster is modeled data, and the black clusters are measured data. So we compare measured with model predicted to show that they actually, the model did really well, predicted what is being recorded. And then we also, for the morphological model, we looked into how the area changed between LiDAR data. We look at, there were two sets of LiDAR data available, 2009 and 2014. So we just subtracted the two LiDAR data set and then resulted in a change in morphology or elevation in a way. And then we the model to predict over the simulate the same period to see what a model came up. So the model predicted very good general trend. And this is just one example showing, you know, elevation change. We also look at the longshore sediment transport, whether they are in the same range. The sediment transport model is usually very challenging, difficult to calibrate because we don't have a lot of available information, you know, what is out there, so that it's more challenging. But overall, we saw the model did really well, predicted the trend, and also the longshore transport rate were in the range of many other studies. Then the calibrated model is used to simulate each alternative under different weather conditions. We look at it under dry weather condition for each alternative. After 5 years of the project, what is the change in the nearshore bathymetry? And then Then, for example, here we are presenting alternative 2 because alternative 2 has the largest excavation volume compared to alternative 3 and 4. So use alternative 2 as example to be presented here. And the image to the right is the difference between alternative 2 and alternative 1 under same dry weather condition. So as you can see, under dry weather condition, we can barely see any difference between existing and the proposed condition. And then under 10 years condition, also you can see there are some slight difference in this area offshore of inlet. If you look at the legend to the right, the color, the difference are very small. It's kind of like a couple inches, if you would say, maybe 0.2 to 0.4 feet of difference in this color. That's that could be very easily a couple of cobble moved because the cobble size are a couple inches. If some of the cobbles are moved during the storm event, then that will result in these differences. But one feature kind of you can see here is dark blue is the erosion in the breach, which we found that under proposed condition, the channel will breach slightly to the west compared to the existing condition. That was that observation was consistent throughout different alternatives. So the same and under 100-year storm event condition. So we think that these difference will lead to potentially westerly breach because of erosion on this. And one of the questions is whether the relocation or removal of the existing helipad and the lifeguard building would have morphological impact to the surfing and the Topanga Delta. So we researched the historical area imagery. When there's really quite some data sets available. One specific standing out is UC Santa Barbara Digital Library has archived images since 1928. We presented a couple representative images here to show that the Topanga Delta, this cobble data point, has been stable since 1928 when the imagery becomes available, as you can see sequentially from 28 to 40. The reason we put it in here is the helipad is added between, I think, in the early 40s. And then this is the 47, see it's very similar. And then we come down to 76. And in the early 80s, there was lifeguard tower added. And then in the mid 80s, a lifeguard building was constructed at this location. And then the last image here is 2010. So really, if you look at this historical changes, you see the lifeguard building, it's a very, and the helipad are very small features when compared to the large cobble delta. So that's why, as you can see, it's still stable over that nearly 70 or 80 years. Actually, from 80s close to 100 years, still to be similar. And another data source we also researched is historical satellite imaging. USGS, in cooperation with university in Australia, they digitized all the historical satellite images since 1984. And then these are the results, as you can see, all the way to 2021 over a 38-year period. And these are the transects. They looked at how the beach will change. It might be difficult to see the color of transect indicating whether the transect is eroding or accreting. If it's a warm color, means that reach is eroding. If it is cool color, is treating. Unfortunately, in this reach, seems like we have 3 segments of which highlighted red over here. 3 segments of beach, all southwest facing, which are facing the wave or eroding. And the Topanga Point and also Maestro Point, because of the Cobble Delta here, and also the shore protection of Maestro Ocean Club, protected down coast beach for a certain distance. So this area are relatively stable in terms of beach width compared to where the red segments. And the other thing I like to point out is you guys are surfers possibly really sensitive to the beach width experience that is seasonal change of beach. The beaches are typically wider in the summer and the fall. After winter storms are become narrow. And the other thing is also more than seasonal, it's a more periodical changes. If we have like El Nino, we have larger winter storm wave impact, and then the beach will become narrow. And then following those events, the beach width kind of recover a little bit. So that kind of represented here in a way you can see those beach widths are up and down. It's not like constant. This change could be more than like 30 or even sometimes become 40, 50 feet wide. So in this area, the difference are actually relatively small, that was 30, 40 feet. Some area regions could be much bigger. And we plotted, well, this is not, we didn't plot, actually, we cited 2 sequence of beach width change from the USGS website called COSAT data. So as you can see for this transect here, in general, you will see that beach width is a little bit getting a little narrower, especially since 90s or 2000. And the transect here immediately east of the Topanga Bridge, the beach widths are relatively stable, but there is a tiny bit of downward trend in recent years. It possibly gets a little narrow. So, so this information, you know, these are long-term trends of shoreline position. And as you can see, there are some erosional hotspots, but otherwise these Topanga Point and like this area, protected area, are relatively stable. And the findings from this modeling exercise and also historical image analysis indicates that the relocation of helipad and lifeguard building would have little impact on adjacent beach under the modeled wave condition and current sea level. And under sea level rise scenario, Dave will present later, talk about what is the potential impact of sea level rise. And the Topanga Point is a large natural feature formed by large volumes of cobbles and boulders. So this feature is very critical and helps stabilize the shoreline at Topanga Point. And the other thing, the project is being very careful in terms of where we grade, how do we grade. Also, all the gradings are landward or beachburn and above +14, except the pilot channel, which under the PCH on the west of the current creek sawwag. During the modeled 100-year fluvial storm event, the inlet bridge slided to the west, as I showed in the previous image, and for all proposed alternatives compared to the existing condition, and erosion occurred in the pilot channel, which could lead to a westerly breach, and is considered favorable for surfing. So that concludes my first presentation. I'm gonna, should I continue to the second one, then will you do the question in the end?
Yeah, I think we should, although if folks want to add some questions to the chat, please do. So Yeah.
Okay, let me, on to
So Weisha, want to make sure that we have time for questions. I know
Oh,
this is
okay.
a
I'm
really
gonna
important thing, and we're at 5:30 right now.
I'll go very
Um,
quick on the second
So,
point.
can you go through this in maybe, 5 minutes, just quick,
Yeah, we'll do very quickly.
please?
So
Okay,
this
thank
is
you.
mainly to look at the nearshore placement dispersal for sediment beneficial reuse. And we try to answer a couple of questions, basically after place, where the material will go, how long will it take those material to disperse, and what kind of material will be remaining on site. So when we consider, consideration being given in terms of where to place these materials. One is surf impact, and we try to stay away from the popular surfing spot because placement will have some turbidity. And the other big point is, avoid impact to existing habitat. And then looking into beneficial reuse is try to maximize the benefit to beach, so place within the depth of closure, so which is about -40. So we want to stay within that, and also look at the constructability to be constructible, reduce impact of potential damage. And one of the things we look at is the question is whether the material can be directly placed on the beach or along the swash zone. But what we found is the material from the lagoon is darker, and also although those gravel size is not that big, kind of within an inch, but some of them have a sharp edge, so it's not really suitable for direct beach placement. That's why we propose the nearshore placement. And also here showing the box is like initially proposed placement location. Try to avoid the habitat shaded area or sensitive habitat area. There were 2022 fall surveys. This was based on their later additional survey was done in the summer of 2023. And then we found that the original placement area in the nearshore area are on top of some of the sand dollar and sand pansies. That's why agencies ask us to look at it. What if we place further offshore? So 3 different locations are modeled. These are the 3 boxes. The initial gray box we modeled, and then the new location, placement locations, green and red, which were recommended by agencies. And this is the initial placement location. Is a 9-acre site, and we'll place 9 feet of materials there between -20 to 25 feet. And these graph shows where the material will go. As you can see, initial box is a square, and after 1 year, twice the material disposed. The disposed material moves towards shore and down coast to the east. And image to the right is after 5 years of placement, more material will move to down coast and towards shore. And then so yes, I'm a little slow. So this is the 2 new site we modeled after the initial placement site, and we also look at a different placement method, as you can see to the right. One is the A is we have a fixed elevation, say 6 feet, place 6 feet from the seabed up. The other is, well, we've placed to a fixed elevation. It's a little easier for the contractor to measure, how measure the quantity of placement. So, and then we also look at, we call the west and the east side. So 4 different additional runs were performed. And here are the results. I'm showing where the material will go once placed and how much time will it take for the mine to disperse. When placed a little further offshore, as you can see here, less material is being dispersed after 1 year, and then to figure to the right is 5. Well, this is after 1 year for different location, different method of placement. Basically, when it is placed in a shallow area where wave energy is higher, more dispersed would occur. But under all scenarios, the material will move towards shore and will benefit down coast beach. So this is after 5-year condition. And one thing we found is, under these conditions, the material dispersed is gradual process over time. The build-up is all less than 2.5 feet outside of placement box. And the revised area avoid the initial placement impact, but will have less dispersal compared to the initially proposed sites. And this is a summary of basically try to see how much material is expected to remain as a placement location, how much is moved. So this dashed line is initially proposed, as you can see. After 1 year, 25% of material will be dispersed. After 5 years, about 35%. But this is, I want to point out, is typically when do sediment transport modeling, we use typical annual wave. If a large storm event, El Nino, were to occur, especially during a low tide, you would expect slightly more material being dispersed. And then these 4 solid lines are the new place location. So you can see the dispersed is less. And in terms of whether the placed material will change the substrate of the existing beach, our conclusion is no, because the grain size are from the excavation side are well within the current the material size currently in the beach or near shore area. So we don't expect that would change anything, would change the impact of the habitat. I think that is my last slide. David, and back to you.
Thank you, Aisha. Let's hold some questions. Please put your questions in the chat and we'll come to them. I'm gonna share my screen and try and go through so we have some time for questions from you all. So let's see, go please. Behave. Okay, so this is the part that really focused on the quality of the surf. That Weisha sort of presented the sediment transport and morphological changes. There was a really cool team that we worked with. We did sort of 2 different pieces. One was the surfer focus group meeting, which helped us identify what sort of swell characteristics we needed to include in the modeling, and then what the perceptions of surfers were on the project. Then we got into the surf impact analysis. I'll talk about some of the surf quality and the surfability metrics, and then kind of show you the results of that. So as has been mentioned, there's these 3 alternatives. Alternative 1 being the no action or existing conditions. And all of these sort of have in common that it's kind of trying to train the creek mouth to realign. Well, they all have a wider span bridge, and all of these have encouraged the creek to kind of migrate to the west. So to me, that's a good thing about this project, because it does help support the surf quality and sediment deposition at the top of the point that can fill in. So this is kind of the projections. This is what happens during a big storm event. You can get this much volume in cubic yards discharged. Alternative 2, 3, and 4, slightly different. Alternative 2 looks like it have the biggest impact on sediment yield. And so we spent a lot of our time focused on alternative 2, and then check the other ones just to make sure that there wasn't anything odd that came out of those. So to me, the purpose of the surf impact analysis was to determine which would have the biggest impact on surf at Topanga Point. Is it a project alternative? Is it the weather? a drought or a flood event, or is it sea level rise? And so we set off to kind of answer those questions. We started with the focus group on July 24th. We did an online and print survey. With that group, we had 110 responses with a pretty good completion rate, and I appreciate everybody who participated in that. And we were really trying to understand what made good surf and experience during different conditions, noting the takeoff location, length of ride, and then to understand sort of the concerns that surfers had about the project and the importance to the local surf community. So the group survey focused on perceptions, concerns about future conditions, and then local knowledge about ideal conditions, waves, tides, and things like that. And so as we got into it, one of the key parts that we really wanted to get at was the wave cases. And so what came out of the survey, and this is actually really a testament to the expertise that the local surf community had. This is the Santa Monica Bay buoy, and you can see sort of the dominant, this is a wave rose. So this is 270-degree waves due west. This is kind of the southwest 200 degree. And this is the conditions that the surfers said was what is represented in the data. And you can see that there's really a strong relationship, almost to the exact number. So with a little bit more west. But to me, this was really profound that you guys have a lot of knowledge and were able to put that into this. So we heard that about 2 to 5 foot was the preferred size swell. It was surfable from 1 to 15 foot. Topanga works on most tides, but it was better at heights below 5 feet, so not high tides. Long period south swells and medium period west swells were most identified as sort of optimal, and that the best conditions for surfing occurred after heavy rainfall and El Nino-like conditions. And everybody said west is best from swell directions. Perceptions of impact on the surf. The surfers were concerned about surfability. There was expected impacts on both average and best conditions. And a little bit of a foreshadowing, the results from the modeling showed, and I'll get into the details of this, but there was minimal impact from the project post-construction, and none of the impacts were detectable after 5 years. The project impacts were within the same range as a flood versus a drought condition. So the project impacts were within the same range of variability in surf quality as a normal year. And then it was found that sea level rise had the largest impact. A little bit of the surfer economics. You guys are dedicated. You surf more often and drive further. The average distance is here. You're willing to sit in traffic during weekdays and a little less on the weekends. Combined of the 110 surveyed, 18,000 surf sessions per year. That's a dedicated tribe there. And if 50% of those sessions were at Topanga, and we take a value of $75 a trip, which is some of the surf economic work that Surfrider and Chad Nelson and others have been doing, that comes up to just of the 110 people surveyed, of $675,000 per year in recreational value. That's a voice, and that's a really important constituent, but it supports the need for the surf science. So what we took from these wave cases were 3 different swells. And so I'm going to kind of get into this a little bit quicker because I want to save time for presentation. So we modeled the wave cases. There was 3 of those, 1 big west, 1 small west, and 1 good south. And Jay, thank you for really nailing those down. different weather conditions, a flood event and a drought, and then different climate with sea level rise over different time periods. So these were the sort of swell and wave conditions. 2 at 15, at 2:30, mid-period west, which is sort of average winter conditions, and then a large west. And we used a mid-tide because that seemed to be, you know, kind of the preferred ideal tide for all conditions. We also looked at a wet year, a 100-year flood event, and that was some of the morphological modeling that Waisha showed, and then which distributes more sediment into the near shore, and then a drought condition where there's no sediment coming out of the lagoon. We looked at a 1-year post-construction and a 5-year post-construction. And for the sea level rise, we looked at 0, 1.6, and 6.6 feet. And this is kind of saying the same thing. It was 26 model runs. So surfability metrics are measured kind of the height of the wave at the location of breaking, and really this concept of a peel angle. And I'll get into that a little bit, but basically the larger the peel angle, the more of a slow, mushy wave it is. And the smaller the peel angle, the faster and more high performance it is. So peel angle is measured as sort of where the whitewater typically occurs, and then where a set wave comes. And that angle between it gives us this peel angle. And again, lower peel angle, faster waves, higher peel angle, mushy waves. This is kind of in that 45 to 60 peel angle is a good takeoff. A cutback is higher in like the 55 to 60. A reentry is more in that 50 range, and then a speed section where you're really driving to make it is sort of in that 35 to 45 range. And there's more information on this, you know, max. The smallest peel angle is sort of a, 27, where professional surfers are able to, execute multiple maneuvers. So keep in mind, low is faster and more high performance, high is mushy. So here's how we simulated those. We ran an X-Beach model, which is a hydrodynamic wave model that allows us to look at sort of breaking wave crests. Each wave then comes in at a slightly different orientation, and we ran 30-minute run times for each wave case. So this is kind of what we get out of that wave model. And we use this. We use those. So every time we have a breaking wave, we basically determine a whitewater path by where all the waves break all the time. And that becomes the wave path on the outside. We considered surfable waves to be the top 1/3 of wave height. So we're not looking at the Grom waves, we're looking at the set waves. So we came up with this path, and you can see where at the top of the point, it kind of turns the corner and then sort of winds down and becomes more maneuverable. We do use these sort of the turning point where it starts to really kind of line up. The restroom, second stairs, and third stairs as we assess the waves in different sections. This is the data we got from you all about where the surfers took off, and it kind of varied based on the different kind of swell conditions. So the peel angle, we took that one heat map, and you'll notice these little pink angles. Every time a set wave crossed that, we were taking the measurements of those and plotting them over time. And so what we got was this scatter plot. And so we had our 3 wave cases. The blue dots were individual measurements of those pink angles. Orange, the same for the mid-size west, and then the big west. And what we see here is that the west swells tend to be, kind of a speedy takeoff, and then it turns the corner and it becomes kind of maneuverable, roundhouses, slower reentries. The south swells tend to be a little bit slower, and then it turns, and then it becomes really fast.
Dave, you're breaking up
Almost
just a
close
little
around the
here.
restrooms, and then if these lines. Hopefully you guys didn't lose me with the unstable internet. So these were some of the key takeaways. But really the long period south was the fastest and typically went to and especially between the restrooms and the second set of stairs. So how was the wave impacted during high creek flow conditions with the restoration? So this is slower at the near the turning, and then it speeds up during the south swell, kind of raised section between the restrooms and second stairs, and then slows back up. What we see after a lot of rain is we get more sediment in that area. With no change is this line here, where it's kind of slower the entire time after a flood, which is very consistent with that observation that the best conditions are following a major flood or El Nino event. And then after the design changes for alternative 2, which is sort of the one that could have the most impact, we see that the wave actually gets better. It gets a little bit faster throughout the entire wave until the inside where it slows down. So it becomes more high performance after 1 year. And after 5 years, you see that with no change, we really are following the same line. So there's really not any effect after 5 years. Looking at the big west swell, we see after 1 year that we don't see much change between any of the swell restoration alternatives, except sort of on the inside where I would expect if sediment deposits that you're going to potentially get more beach and potentially more closed out stuff. Sorry, my dog wants to say hi. And we didn't look at when I'm not reporting all these results, they're all in the technical report. But after 5 years, there wasn't really a change at 1, so we didn't expect one at 5. So for alternative 2, the one that could have the biggest potential impact on sediment supply, the highest potential impact following a flood event would be on long period south swells, and it gets better. Much less impact for mid-period west or big west. And it tends to be that following construction, the peel angle is lower, so we get a little bit steeper and faster waves. But all of these things are sort of moved through the system within 5 years. So what about droughts? So basically, again, the one that had the biggest impact in sort of the flood events was the south period. So we started there. And basically we see that after a dry year, the overall peel angle is higher for both conditions, and a second, and really it does clean up between the restrooms and the second stairs following either of the restoration alternatives. And after 5 years, there's really not much of an impact. In the big west swell, we also don't see much difference except toward the end of the ride where it tends to be a little bit slower. So the key takeaways from the surf quality impact assessment were that the highest impact was felt for long period south swells, and it basically made the wave better. The less impact for mid-period west swells or big west swells. And the peel angle actually got higher, meaning it was softer waves, slower. after a dry year, so you don't have the same amount of sand and sediment on the cobbles. But one of the most important things that all of the impacts after 5 years were not detectable. So then we asked the final question, what happens with sea level rise? We looked at 1.6 feet of sea level rise by about 2045 and the south long period swell. Adding 1.6 feet to a 3-foot high tide that we did the analysis on gives you a really high tide, but it's basically the same as it is today. With a sea level rise of 6.6 feet, which is here, you start to see a lot of closing out at the restrooms, particularly this considers that the restroom is in place. You're not going to make this section any longer because it's going to be breaking on the revetment. So, and the top of the point is also becomes really difficult to make. So, without removing the restrooms and considering sea level rise, you're going to really break up the surf spot. So it sort of indicates that this needs to go if the surf spot's going to be maintained in the future. And that's kind of what I just said. Waves will be breaking to the back of the beach. And by that point, PCH and everything else will have a lot bigger problems than the surf quality here. But this is definitely was an interesting finding. So in conclusion, sea level rise was the biggest culprit for the impact on surf quality. The surf impacts from the project are about the same as a flood versus drought year within the natural variability of weather. Differences between project alternatives really occurred primarily around the takeoff location. Alternative 2 had a short-term beneficial impact on a south swell, none after 5 years. Alternative 3 and 4 impacted the takeoff the most. There's more details in the report. It's not a big, huge difference. I think in the shoreline change analysis, the western alignment of the creek outlet resulted in larger down coast beaches. And so the project restoration, which is trying to kind of encourage the creek to migrate to the west, seems to provide wider beaches, and based on input from you all, also encourages sort of a better surf condition. So at that point, I want to just open it up for some questions. I'm not sure how much time because I was just talking, but I'm happy to stay for a few more minutes if there are some questions. And again, the reports are in here. You can get them both at the website for public comments, and then the direct link to the EIR technical appendices are here.
Thanks so much, Dave. We do have a few questions. So Jay asked, did the surf quality impact analysis include study of the nearshore placement of the relocated sediment?
So the answer is no. Unmute. Dave need unmute. So the answer is no. The placement was mostly avoided the surfing area, kind of in the midpoint to the east, midpoint between inlet and Topanga Canyon Boulevard. The placement is further to the east of popular surfing location from Dave's study. Dave, Rose, can you unmute Dave?
I did. So Dave, you need to now unmute yourself because I
did.
Okay, we can hear you.
Okay, good. Yes, so we did not apply the same surf quality peel angle analysis to the sediment placement. That work was kind of done sort of simultaneously, and so we didn't have that sort of in time to do that.
Okay, thanks. is there a viable reuse opportunity for the sediment as an alternative to placement offshore? I'll start to tackle that, but the cost of transporting and the truck use of transporting the material is what we were trying to avoid. But, you know, this is not a done deal yet in terms of what the final analysis will be. We have submitted these reports to the dredge management team, and we're waiting to have their response back. Chris Webb, did you want to add anything else to that? I just unmuted you. Or did I capture
Before
that?
Chris get on, maybe if I use the wrong terminology, I apologize. We supposed to say place nearshore, not offshore. Those are all still offshore. Nearshore. Offshore is much deeper when we're talking about the dredging material disposal. Chris, go ahead.
Hi, thank you. I appreciate that. So the idea of putting the material within the littoral zone in the nearshore was an effort to try to feed a denuded littoral cell with sediment right now, because the sand supply to this littoral cell is significantly reduced from historic levels, and the beaches are retreating. We saw that in the shoreline position analysis that Weisha had showed earlier. So our effort was to try to provide a benefit from the project. And in doing that, if it doesn't affect surfing adversely, which we don't think it will, because we intentionally put it farther east from the surf location, and our modeling and our common sense and just understanding of the system is that the material will head east rather than west, so it won't go back to the surf spot, wouldn't affect surfing. It would benefit the shoreline, and then it takes away from potential impacts that would occur from truck hauling the material to upland landfills, and traffic impacts and energy usage and air quality and all that stuff. So we just felt it was much more beneficial to put material in the nearshore off of the shoreline for multiple benefits.
Okay. Ed made a comment that he's noting that chronic erosion hotspots are not far up and down the coast. And that's really what, Weisha's modeling documented as well. So thanks for that comment, Ed. Jay had another question. He said the objectives outcomes section of the report suggests that alternative 4 would protect the beach and surf, favored over alternative 2. Could you speak briefly to why alternative 4 is preferable?
So alternative 4, and give me just a quick second. Alternative 4, and sorry if you guys are getting seasick here, but alternative 4 was really much closer in the amount of sediment discharge, and it didn't change the takeoffs. The takeoff spot changed the least. So there was a little bit more of that. I think there was probably also some location, and this is something that maybe Weisha or Chris could talk to about where the sediment is deposited west, along the western alignment of the project.
Yeah, from sediment morphology modeling, the difference are so small between each alternatives. How that would change the topography of the Topanga Point I'm talking about from fluvial sediment input. So the difference between alternatives is really small. It is almost compared to the large amount of sediment come from the watershed during a large storm event. That's really negligible differences. And also, actually, we had 2 habitat survey. The biologists, they did a survey, they observed that, even just a seasonal change in that area could be half foot a foot between the 2 surveys last October of 2020 to October to July 2023. So all these changes are really within the seasonal variability. The alternative itself really doesn't make much difference in terms of how impact to the nearshore bathymetry.
Thanks, Weisha. It's now 5 minutes after 6, and we've, gone a little bit over. I don't see any more questions in the chat. Does anyone want to raise their hand or add any more questions real quick? So, oh, Jay, go ahead. Hang on just a second. Let me figure out how to. I have to ask you to unmute, and then you have to unmute yourself.
There we go. I just wanted to say on behalf of myself, and I think speaking for Friends of Topanga Point, we really appreciate all the attention to detail and the science that went into this, and haven't had a chance to read the entire report, but in skimming it and reading the the addendums, I can really tell that you all put a lot of effort into it and listened to the questions we were raising and the issues that we had. And I just want to say I really appreciate it from all of you. So thank you very much.
Well, we were happy to do it because we had questions too. And Aaron, I think I just unmuted you, so check and see if you can speak now.
Hi, can you hear me?
Yes.
Hey, I just wanted to echo Jay's comments right there. I'm really impressed by this presentation. I've been in front of a lot of agencies. I've seen a lot of presentations. I'm deeply impressed by what you've done today. We're going to review the material, but the level of detail you shared with us and the questions you answered in your presentation without us asking was really phenomenal. So thank you very much.
Well, that's great. I'm glad that it looks like. So a couple of folks were asking where to get the reports and where to put your comments. So the reports, everything's on the Topanga Lagoon Restoration website. So if you go to that, Jelly just added it into the chat as well. You can get everything that you, all the reports, all the appendices, everything that we've been sharing. We apologize for the delay in getting it all out to you. We had hoped that we would have been a little bit earlier, but we are still continuing to have a 60-day public comment period. So you have some time to take a look at this, read the reports, digest it. And we would like to encourage you to come to either one of the public meetings, the formal public meetings. There's going to be one at the Annenberg Beach House on this Saturday, the 24th from 10 to noon. And that is both in person and live streamed. And then there'll be the exact same presentation shared with everyone at the Topanga Community Center on Wednesday, the 28th of February from 6 to 8 p.m. So hopefully you'll be able to come to one or both of those, and that'll give you, sort of a bigger, broader picture of the whole integrated project. We just really wanted to spend time tonight focused solely on the surfing questions and issues. So hopefully it's been helpful. And we really appreciate everybody's engagement in this. And thank you all for all your help and guidance on this. And stay safe out there. Don't get caught by any of those big rogue waves that are coming in, and enjoy the surf. So thanks, everyone. Have a lovely evening.
Thank you.
Bye-bye.
Bye.
Oh, Charlie, I just saw you asked if there'll be one in Malibu. No. And these are the two public meetings scheduled. So, all righty. Thanks all. Have a good evening.